Hello and welcome back to another video. Today we're going to be looking at indices or exponents, or powers, whatever you want to call it. Okay, so to start off, I'd like to say that this is 2 raised to the power 2. So what does this really mean? This is the base because it's a bigger number. We call it the base, and this is the power or the exponent or whatever you want to call it. So this is the base and power. Power is just easier to write. Okay, so what does this really tell us? It tells us that 2 is multiplying itself twice. It gives us 4. Okay, what if we have 2 to the power 2 times 2 times 2? Well, that will just be 2 to the power 3. 2 is multiplying itself 3 times. That's what really this notation is used for. Okay, but let's move on to the real work of the day. Okay, so first of all, this is called the power of addition law or whatever you want to call it. So here we add powers when the bases are the same. So you can see the base here is the same. So we can just add the powers. Yeah, it's simple as that. So if you have something like 5 to the power 2 times, let's say 5 to the power 3, you'll get 5 to the power 5. That's it. And you can use this as for variables as well. So let's say we had x here, we had x here, so you'd have x here, right? Simple as that. Okay, so this is the same thing for division. If the bases are the same, you can subtract the powers if it's division. Okay, so x to the power 3 times, or no, divided by x to the power, let's say 2, that'll just give us x to the power 3 minus 2, which is just 1, or just x. Okay, so alright, the next one is the power distribution. So here you just multiply the power outside the bracket by every single power inside the bracket. Alright, so that's just, as you can see, a to the power mn. So if you have something like 5x squared, and then the power is, let's say, 2, okay, you can write this as 5 to the power 2, x to the power 4. Well, you can obviously write this as 25 and then x to the power 4. Alright, so next is just telling you that if you have two numbers, let's say 5x, no, let's not use 5. Let's say 2 to the power 2, x to the power 2, and y to the power 2. You can rewrite this as 2xy and take the power out completely. Because when you distribute the power, it will still give you this thing. Alright, so that's just a simplification. It's not really a law, but we're using it anyway. Here is the same thing, but it's in fractions. So if you have a, let's say x, and then here you have y, and they have power of, let's say, 2 and 2, you can write this as x over y power 2. There's not really much detail to go into for this one. It's just the power can be, factored out. This is just okay. So number 6 is just really something that you have to remember. So if you have, let's say, 5 to the power 1 times 5 to the power minus 1. So when you add the powers, you'll get 0, right? So this will be 5 to the power 0, and it's always equals to 1. So next is a could be anything. So let's say x to the power minus 2. This can be written as 1 over x squared. Or if you have 1 over x to the power minus 2, this can be written as x to the power 2. Alright, so the minus indicates if it can be like 1 over something. Okay, next is x to the power 1 over n. So n can be 2, and could be any number basically. Okay, so this can be written as square root of x, or x could be, x to the power 1 over 3. This would be cube root of x. Right, so that's pretty much it. We don't really write the 2 here, but it's there. And then you have a to the power, let's say, 1 over 4. I should use like 3 over 4 maybe. So this will give you square root, or just the root sign, and then a. So the n power, which is this one, will go outside, and the top one will go up there. So that's pretty much it. Those are all the laws you have to know. Okay, so let's get started with this one. First of all, we're going to simplify it. And to simplify it, we're going to, first of all, add the power here. there's a power there, there's a power here. But before I do that, before I even do that, I need to simplify it even further so that it's easier to look at. So we have 4x squared y all squared multiplied by 9x power 6 y squared, and this is also power half because it's a square root, so we can write this as power of half, and then all of that over x to the power 3 y to the power 2 all to the power minus 2. Alright, so what do we do next? We're going to start distributing the power. So this is the power of 1, this is the power of 1, this is the power of 1. That'll come in handy because when we're multiplying the powers, we will know what to do. Alright, so 4 squared x to the power 4 and y to the power 2 multiplied by 9 to the power half, x to the power 6 over 2, which is 3, and then y to the power 2 over 2, which is 1. Okay, and then x to the power 3 times minus 2, which is minus 6, and then y to the power minus 4, because 2 times minus 2 is minus 4. Alright, from here, what you have to do is you have to look at the like terms in a way. So you're going to take this, the integers, you're going to multiply them, because we're multiplying here. Okay, next you're going to take the x terms, multiply them out, and take the y terms, multiply them out. We're going to deal with the numerator first, then we'll come down to the denominator. Okay, so 16 times 3, I'll give us 48. Then x to the power 4 times x to the power 3, which is x to the power 7. Then y to the power 2 times y to the power 1, which is y to the power 3. Over x to the power minus 6, y to the power minus 4. Okay, now we don't really have any other integer term to multiply or divide, so we're just going to leave 48 the way it is. And then we're going to move on to our other terms. X to the power 7, so now divided by x to the power minus 6, x to the power 7 minus x to the power 6, x to the power 13. Okay, so 48 x to the power 13. And then y to the power 3 over y to the power minus 4. That will be y to the power 3 minus 4, which is y to the power 7. Okay. So that is the simplified form of that. Alright, let's move on to question number 2. Alright, so in this one we're going to do the same method. So you should try it out first. So 9x to the power 8, y to the power minus 4, power half, times 8, x to the power 6, y to the power minus 3, then power 1 over 3, because cube root. Okay, so let's distribute the power out. 9 to the power half. Okay, 9 to the power half, x to the power 8 over 2, which is 4, then y minus 2, minus 4 times half is minus 2, times 8 to the power 1/3, x to the power 2, 6 times 1/3 is 2, and then y to the power minus 1. Okay, we're going to do the same method, multiply out the integers, then multiply out the x's, then multiply out the y's, and that should be it. So 9 to the power half times 8 to the power 1/3 gives us 6. And then x to the power 4 times x to the power 2 is x to the power 6. And then y to the power minus 2 times y to the power minus 1 will be y to the power minus 2 plus minus 1. So that will be y to the power minus 3. And that's all. That is a simplified form of that. This is a bit of a tricky question, so let's get started. It says, given that this expression, find the value of x and y. Okay, so we're going to quickly go over this. So a to the power 2x, right, times b to the power y minus 4 over b to the power 5 minus x over a to the power y is equals to a to the squared, and then b to the power 4. Now, before we continue, I need to mention something, that when you have something like, a over b times c over d, the denominators and numerators can be swapped. So like a and c can swap positions, b and d can swap positions. So you can have a over d times c over b, and it's still the same thing. So you get AC over BD, it doesn't matter. So like their positions does not matter. So these can change positions and these can change positions. Okay? Horizontally, not vertically. Okay. So let's move on. So we're going to write a to the power 2x over a to the power y times b to the power y minus 4 over b to the power 5 minus x equals to a to the power 2 b to the power 4. Now, these two have the same bases, so we can just subtract them. A to the power 2x minus y times b to the power y minus 4 minus 5 minus x. Remember to subtract the entire power, not just, minus 5 minus x. So this is power 4, power 2, and then this power 4. Okay, let's simplify this one. We get b to the power y, that should become plus x, and minus 9. A to the power 2x minus y, and then multiplying the other term, and we get here. Okay, so in the next step, what we're going to do is we are going to look at both of the expressions, both of the sides. So here it says, here we have an a, here we have an a. We have a power, So what we can say is, in a way, just use a different color, a to the power 2x minus y is equals to a to the power 2. And then we can say b to the power y plus x minus 9 is equals to b to the power 4. Okay, so here what we can say is, well, since the bases are the same and they're equal, right? So that means the powers must be the same as well. So we can say 2x minus y is equal to 2, y plus x minus 9 equals to 4. All right. Next, what we're going to do is, well, this is just simultaneous equation. So 2x minus 2 equals to y, and then x plus y is equals to 13. Let's just put x plus 2x minus 2. This is y. This is x, still equals to 13. This will give us 3x equals to 15, because minus 2 goes to the other side, becomes plus 2, and 13 plus 2 is 15. Then over 3, x is equals to 5. And 2 times 5 minus 2 is equals to y. 10 minus 2 is 8. 8 is equals to y. So our answers for this is 8 is equals to y and 5 is equals to x. Okay, so these two are the answers for this equation. Okay, so that's all for today. So we're gonna call it a day from here. And I hope you understood everything that I've said in this video. And next time we meet, we're going to expand on this topic and move into inserts.